If you know what this is and where it's used in a 3D printer, well done. You've probably been around for a while. This is a hobbed bolt, and it's one of these slightly weird parts in a 3D printer. Well, it's been replaced by other bits for the most part. I know I've been using terminology for all these parts in the other basics videos without really stopping to explain them. So in this video, let's go over all the weird and unique parts, what they're called and what they do. Also, while we're at it, let's look at what sort of maintenance and care these machines and their components need. This video is brought to you by Do It 3D. The Do It 2 mainboards are already some of the best boards you can use for a 3D printer or CNC machine, and the new Do It 3 now offers massive expandability if you want to drive, for example, over 24 stepper motors. All Do It 3D boards use genuine trinamic drivers and high-efficiency MOSFETs to run smooth, cool, and reliably. And of course, their firmware and board hardware is completely open source. They're available from resellers all around the world. Check them out at the link below. Okay, so let's start with the core of any filament printer, the extruder and the hotend. To feed filament, it first gets grabbed by the extruder and then pushed into the hotend, either directly or through a Bowden tube. Inside the extruder, the hobbed bolt, or in newer machines the hobbed gear or drive gear, engages with the filament, and that filament is either pushed into that gear with a spring-loaded idler or with a second drive gear in a dual drive setup. I guess the term gear is a bit misleading because even though the surface of a hobbed gear where it's grabbing the filament kind of looks like a gear, but an actual spur gear is a pretty bad choice since it's too coarse and not sharp enough to really bite into the filament. As far as maintenance goes, there's not much to do here. If your extruder lets you adjust the spring tension, it only needs to be enough to not slip on the filament. As with all moving parts, the bearings need to be able to move freely. For all these maintenance jobs, I'll try to roughly rate how often you need to do them in printed filament spools. Checking if the extruder bearing has seized or is running rough is something that you only need to do, about probably 50 spools or more. If you're having printing problems, you should also give the drive surface of that extruder gear a look. If it's clogged up with filament shavings, there's something wrong in your extrusion path, and even though it's rarely the extruder itself causing it, it never hurts to check the idler spring tension. Every 20 spools or so, you should also check that the teeth haven't worn down or dulled, probably more often if you're printing aggressive filaments like carbon-filled materials. Moving down to the hotend, that's made from 4 main parts usually. Starting at the bottom, you've got the nozzle, which is threaded into the heater block. Then that's mounted to the heat sink with the heat break. Some hotends look a bit different, but the basic functionality is the same. The heat break's job is to mechanically support the heater block and to only allow as little heat as possible to travel up into the heatsink. So the heatsink's job is not to cool down the heater block at all. You're actually trying to keep that warm, but only to keep the upper half of the heat break cool enough to function. Half molten filament is already sticky, but doesn't flow well yet, so that transition state is something that needs to be avoided. To assist with temperature control, almost all hotends have a cooling fan, which either turns on when the hotend reaches a set temperature or is simply always on. The other fan you'll find on the toolhead is the part cooling fan. This one is angled down and blows cool air over the print as it's being built up, and that fan will be turned on or regulated as needed. You might also find a bed leveling sensor. Depending on how they work, they can look quite different. In the heater block of the hotend, you'll find a heater cartridge and a thermistor, which measures the temperature. The nozzle, heater block, heat break, heater cartridge, and the thermistor make up the hot side of a hotend. I mean, they're all hot in use and you probably shouldn't touch them. So for maintenance, starting with the 2 fans on the toolhead, every 2 or 5 spools you should check that they are free of dust and can spin freely. If they're dusty, blow them out with some compressed or canned air, but hold the fan blades so that they don't go spinning crazy fast. I know that's fun, so I'll do it for you once so that you don't have to. Ready? That was loud. Okay. These fans turn into generators when you spin them, and that can damage the fan itself or, worst case, the rest of the printer's electronics. Though that's pretty unlikely. Also make sure the part cooling fan doesn't blow over your hotend's nozzle or heater block. You'll always get some airflow over the heated parts, but try to keep it to a minimum by either adjusting where the fan blows or by printing and using a different fan duct. Also, occasionally give the thermistor a good look and make sure it's still held in place properly. You definitely don't want this to fall out. Its leads are delicate, so be careful with them. Something that can help to keep your hotend working well is to keep the insides clean. An easy way to do that is a cold pull, which you usually don't have to do more often than every 2 or 3 spools, if at all. Load some filament into the hotend, usually you'd use nylon here, but PTG also works. Then let it completely cool down. Now, what you want to do is to heat it up again, but keep trying to pull it out of the hotend by hand while it's getting up to temperature. At some point between 50 and 100 degrees Celsius on the hotend, the filament should come out and, if it worked, should have a perfect impression of the inside of the nozzle. What this does is to take out charred debris that won't fit down through the nozzle and might clog it at some point. How much of that stuff accumulates heavily depends on the filament you use and how you print it, so you might have to repeat the process to get it perfectly clean. If you have a Bowden setup, it's a good idea to remove the Bowden tube first so that it can feed and pull on the filament directly on the hotend. On a lined hotend, the lining itself can also degrade over time. Depending on how exactly your printer is built, check it about every 10 to 20 spools. If there is visible deformation or you see darker toasted spots, you can usually just cut off the end and feed it back in. Getting a square and straight cut is important here. Obviously, this will make the Bowden tube a bit shorter, so after a while it might become too short and will need to be replaced. But the standard 4x2mm PTFE tube is pretty cheap. Bowden tubes also wear down over time, so replacing them every now and then is probably not too bad of an idea anyway. But whether you can just cut off the Bowden and liner tube, and whether that same tube is even going all the way down into the hot side, or if there's a separate piece of PTFE just going through the heat break, that will depend on how exactly your printer is built. There are plenty of variations, and covering them all would be a bit too much now. The last thing on the hotend is the nozzle itself. A standard brass nozzle can last a long time if you only ever print PLA. But especially materials with added fibers or metal particles can wear down a nozzle fairly quickly. So for those, you should never use just a brass nozzle in the first place, but instead go for a special wear-resistant one. In either case, if you're noticing the flat area around your nozzle's orifice getting wider, it's either time to see a doctor or to replace your printer's nozzle. Follow the manufacturer's instructions for how to disassemble and reassemble these parts. If you're strong-arming stuff, you're probably about to break something. So, I think that covers the toolhead. Let's move on to mechanics. Starting with the linear motion system. Your X, Y, and Z axes usually run on either round, smooth rods and linear bearings, or bushings, linear rails, or on V-slot aluminum profiles or extrusions with V wheels. You might also hear this system referred to as open builds, as they are the ones that came up with it. Driving the axes, you've got toothed belts, which are driven by the pulley that's sitting on the stepper motor and are looped back with an idler. For the vertical Z-axis, you've usually got a lead screw and a lead screw nut, or sometimes a ball screw. Usually you'll find end stops on the ends of each axis, telling the printer when it has reached the end of its allowable motion range. For linear guides using linear bearings, it's important to keep the rods they run on free of dust and debris. These bearings have wipers that will shove dust away, but not letting dust or especially sand get onto them is a good bit of prevention. These rods will also naturally be oily, and that's a good thing. The bearings themselves are lubricated. If you can stay on top of it, it's certainly not a bad idea to add a drop of medium viscosity oil onto the ends. If you can stay on top of it, it's certainly not a bad idea to add a drop of medium viscosity oil onto the ends of the bearings after each spool of filament, just to keep it all nice and lubricated. But if you prefer a more thorough but less frequent schedule, you can also take out the bearings every 10 to 20 spools or so and pack them with grease. There are some good printable helpers available for this. On V-slot designs, you'll get a bit of rub-off from the plastic wheels, which can bunch up as bumps and create issues on your prints. Remove those as soon as you see them. Also wipe down the aluminum V-slot extrusion itself to pick up any rub-off before it can cake on. The bearings inside these wheels should be manufactured with a lifetime grease packing, so you don't have to worry about them. But because the wheels themselves wear down and can lose their adjustment, you will need to periodically adjust the tension on them. Check every 2 or 3 spools if you can feel any slop in the carriages. For the belts, there's little periodic maintenance to be done. But while the printer is still new and things are settling in, it's a good idea to check the belt tension every spool or so. When you plug it, it should be in the frequency range of a bass guitar. If it's not, your belt tension is probably off. And for lead screws, a bit of grease every now and then certainly doesn't hurt. As lead screws are a sliding mate and not a rolling one like bearings, oil instead of grease is probably too thin here. One last note on every linear axis. You are able to move them around by hand when the printer is off, but try not to jerk them too fast. When a stepper motor is spun up externally, just like a fan, it acts as a generator, and that backwards current can destroy or damage its driver chip. Typically on the y-axis of a printer, you've got your print bed. If it's heated, it's a heated bed. Genius, isn't it? Common ways of building bed heaters are using an aluminum core PCB, a regular PCB, that's a printed circuit board by the way, or using a silicone heater and a sheet of aluminum. On top you've got the bed surface using either a Build-Tack style sticker, this is typically a textured polycarbonate film, or a PEI film also applied with double-sided adhesive, or a powder-coated textured PEI surface. If your printer just has a plain glass or aluminum surface, usually you have to use a bed adhesive that is sprayed or brushed on. On glass, just a clean surface with nothing on it will often work fine for PLA. There are different grades of glass. The one you will often hear is borosilicate glass, as that is more temperature resistant than plain soda lime glass. The most important part to maintaining a bed is to keep it clean. Dust and finger oil can decrease adhesion and lead to lifting prints. A good cleaning agent is a roughly 50-50 mix of water and ethanol, also known as vodka. The alcohol will remove grease and the water will take care of other contamination that might not dissolve in pure alcohol. Depending on how much you touch your bed surface and what material combination of surface and filament you use, a quick wipe down every 5 prints should keep it perfectly serviceable. If you use an additional adhesive, remove or reapply according to the manufacturer's instructions. The other part to getting prints to stick is a level, well technically trammed bed, and a correctly set nozzle distance for the first layer. We'll be looking at those in video number 9, as they are not something that necessarily needs to be adjusted or checked in fixed intervals. Usually you set it up once and only need to touch it if stuff starts going wrong. Okay, so let's move on to the electronics. The main components are a power supply, which is external to this one, so I'll use this guy to demonstrate. A mainboard with stepper drivers, either soldered on or as Pololo style modules, as well as peripherals like an LCD screen or an LCD controller. On the mainboard you have a microcontroller, which contains the processor managing the entire printer. MOSFETs, switching the current to the hot end heaters and the heated bed, and connectors for thermistors, stepper motors, heaters, and other components. Since these are solid state components with absolutely no moving parts, there's nothing to really service here. But you should check every now and then, 10-20 spools maybe, that there is no discoloration from heat on the PCB, components or cables, and that these screw connectors are still tight. Depending on how these were originally assembled, it may be necessary to retighten them at least once after the cable you're clamping has settled. The other thing you should keep an eye on for wiring is that there are no spots that are chafing or where a cable keeps sharply bending in the same spot. Alright, so that should cover the basic components and maintenance of the printer itself. There's really not that much to it. There is still some terminology to be had with the actual print and all the features on that, but I'll be covering those in the Slicer Basics video, as that's where those will become relevant. So lastly here, I want to give you a quick overview on the filament types that you're going to be printing and what they're being used for. Starting with the most common one, PLA is polylactic acid, and it's made from cornstarch, or basically other sources of sugar. It is generally the easiest material to print because of its low tendency of warping and good layer adhesion, even when printed at room temperature, ambient temperature. PETG is part of the polyester family, and it's polyethylene modified with glycol. The G makes it tougher, but softer, but in general, polyesters are more temperature resistant than PLA. It can be printed on most printers, well, almost any printer, but if the ambient temperature is too low, it can start curling and cracking. Also, it will stick way too well to PEI film like this and to plain bed surfaces, and it can easily take out chunks out of those when removing the print. On the other hand, getting stuff like paints or glues to stick reliable to polyesters can be kind of tricky. A lot of materials that come with fancy brand names are based on polyester, so they are going to be similar to PETGs. The styrene-based family of filaments includes ABS, ASA, and HIPS. Those are acrylonitrile butadiene styrene, acrylonitrile styrene acrylate, and high-impact polystyrene. They are fairly similar materials, all requiring a printer enclosure for best results, and the finished parts providing good temperature resistance. In turn, they require fairly high print temperatures, so printers with a lined hotend are not the best choice for them. PC, polycarbonate, is an incredibly strong plastic and has excellent temperature resistance, but just like the styrene materials, even more so, it does require an enclosure or an elevated room temperature to print reliably, as well as an all-metal hotend. Polyamides, also known as the brand name nylon, they come in a wide range of properties. Generally, they are very tough and hard-wearing, but can be very tricky to print and to keep stuck down onto a printer's bed. They are also nearly impossible to paint or glue with common materials. Flexible filaments, also abbreviated as TPU or TPE, have a wide range of properties that they can come in as well. They will usually stick very well to a bed surface or other materials, but because they are soft, they can be tricky to print in a Bowden setup. And lastly, well, not quite, there's the water-soluble PVA family of materials, polyvinyl acetate, and similar materials like BVOH. These are mostly used for dissolvable support material in prints, but if you need, for example, a print that dissolves in the rain, then these can be incredibly useful for that as well. More recently, PP, polypropylene, has also gained in popularity. It is a material that is in a lot of ways similar to PETG, but is mechanically very tough. Alright, so that should give you a good overview of what those fancy terms are that describe the parts on these machines, and give you a primer of what kind of TLC these machines need every now and then. Please keep in mind that because there is more than just one model of printer, some of these maintenance jobs and the intervals that I came up with may be different for the exact machine that you have. So if you have instructions by the manufacturer that contradict what I just told you, preferably stick to those instructions, not mine. I just don't want to be responsible for that. And of course, use common sense. If something looks wrong or makes a weird noise, fix it before it gets worse. So I'm not going to recap this video, I'd have to repeat the entire thing. So thank you for watching, make sure to get subscribed, keep on making, and I will see you later.